Alright, here's section 3.1. As always, please make sure you are showing all of your work and how you got these answers, especially for the warm-ups. That is what I'm checking to ensure that you are doing the math correctly, but not so you can watch me do questions that you know how to do or that are review. If you are having questions on them or you're not getting the same answer I am, please stop and raise your hand so I can help you. So for the first warm-up, you should have gotten 4, -2, -3, 4, and no solution. Again, I'm going to check when I check your work that you have done these problems out. All right, and this one, graph the function, label the vertex and axis of symmetry. I use transformations to graph these. So for the first equation, knowing that the vertex was at -4, 0, that's how I graphed it. There's my vertex, there's my axis of symmetry. You can see below I found 2 other points. And then again for number 2, I used the fact that it was shifted over to the right 2 and down 6. So that would be the vertex right here. Graphed my points, labeled my axis of symmetry, labeled my vertex, wrote what the axis of symmetry was, and then there's my points and how I plugged them in. So now we're going to jump right into it. Oh, for these as well. So for this one, it's going to be reflected, and I want you to show me where this one is, and for number 4. So when you have those 2 answers, pause the video, raise your hand, and show me. So how can you use the graph of a quadratic equation to determine the number of real solutions of the equation? So we want to find out what real solutions are, where they cross the x-axis. All right, so where something crosses the x-axis is the solution. Now, this is asked in several ways. You could be asked for the x-intercepts. You could be asked to find the roots. You could be asked to find the zeros. You could be asked to find the solutions. All of these ways do the same thing. They tell you where it crosses the x-axis. Let's say you have a graph, though, that doesn't cross the x-axis. Then how many solutions do you have? Well, in this case, there would be no real solutions. I'm not saying there aren't going to be imaginary solutions, and this is slowly leading up to that. But for now, we have no real solution. So solving quadratic equations. So there are 3 ways to solve. There's another way. There's 4 ways. To solve quadratic equations, you can solve by graphing. You can solve by using square roots. You can solve by factoring. Or the last way is to use the quadratic formula. I don't know why that's not in this lesson. But the quadratic formula is -b over b squared minus 4ac divided by 2a. So these are the 4 ways that you can find the roots, find the solution, find the x-intercepts, find the solution. So we're going to focus largely today on graphing square roots, and I'm going to throw some factoring in there while we're at it. So let's solve each of these by graphing. So I look at equation number 1, and if I start thinking -b over 2a, I can see that that's quickly going to lead to a fraction. I can do it, I just don't want to. So I also look and I was like, can I factor that? Can I factor x squared minus x minus 6? And I can. So I'm going to factor this by breaking up this 6. So 1 times 6 is 6. How am I going to get -1? Well, -3x plus 2x will give me 6, right? If I multiply 3 times 2, I get 6. And when I add these 2 middle terms together, I get -1. So now I'm going to GCF. I'm going to GCF the first one. What do I mean by GCF? Well, I'm going to take the greatest common factor out of that one. So when I take the greatest common factor out of that one, I get x minus 3. Then I go to my second one. And I take the greatest common factor of that. So the greatest common factor between 2x and 6 is 2. And that also leaves me with x minus 3. Now, these, when you do it this way, I want the highlighter, will always be the same. So then in factored form, this is x plus 2 and x minus 3. Now this is all still equal to 0. All of these are equal to 0. So now I have x plus 2 equal to 0, and x minus 3 equal to 0. So x is equal to -2 and x is equal to 3. Well, I can go graph those right here, -2 and 3. Now what I need is the halfway point. So I have these two dots. I know that this is the x-intercepts. We talked about that in the last unit. Okay, so I know that this is my x-intercept if I had to label it. And this is my x-intercept. But what I need is the vertex. So how can I find the vertex? Well, I could still do -b over 2, 1, or I can find the midway point of these two. So the midway point between those two is going to be 1/2. So I know what 1/2 here, approximately, this very badly drawn straight line right there, that's my axis of symmetry. Now I can take this 1/2 and plug it in. Which when I do that, I'm going to use the calculator for this. This gives me -6.25. So 1, 2, 3, 4, 5, 6. So at about 0.25 I put a dot. And there's my graph. Alright, now this one here, I don't know why I didn't delete it before I printed it, but that's on this page. So it gets its own page. So now I'm going to move these all to the other side. So I have one side equal to 0. Plus 4x plus 2. Now I'm going to factor out the 2. And I know that this can be factored. And the 2x plus x plus x plus 1. And I could GCF those. And I could GCF those. Leaving the 2 out there. So this is going to give me x plus 1 times x plus 1 equals 0. So what does that mean x is equal to? X is equal to -1. So that's going to go right there. Now, because it's right on it, and there's no other dot, I know that this is the only one on here. This is the only place it crosses the x-axis. So I know that's also the vertex. And if you plug in -1 to this, you are going to get 0. That's 0. So I know that this is also my vertex, which means this is also my axis of symmetry. That's the vertex, and it's also the only x-intercept. So now I can find two other points just by creating my chart. So now I can use 0 and 1. So what happens when I use 0 and 1? So this is 2 and 2. This graph's going to look something like this. So then the solution to this, or where its 0 is, where its x-intercept is, where its solution is at -1. Alright, solve by graphing. So again, can I factor this? That's always step 1. Can I factor? If I can, life's a little easier. So I can factor this. So I need the factors of 12 that are going to add to give me -8. So that's going to be 6 and 2. So I have x squared minus 6x minus 2x plus 12. I am going to GCF these two, and then I'm going to GCF these two. Okay, so I GCF those, I get x minus 6, then I get x minus 6. These will always be the same. If you factored correctly, these two will always be the same. So then I have x minus 2, x minus 6. So x minus 2 is equal to 0, x is equal to 2, x is equal to 6. Alright, that's the x-intercepts, that's the solution, that's the zeros, that's the roots. Roots is the one I always forget. So now I need to find the midway point so I can find the vertex. So the halfway point between 2 and 6 is going to be 4. So I know that my axis of symmetry is 4. Now I can just take the 4 and plug it in. So 4 squared minus 8 times 4 plus 12 16 minus 32 plus 12 is negative 4. So my vertex is at 4, negative 4. If I had to label all the graphs, I would label these the x-intercept. I'd label this the vertex or the minimum point, and I would label this the axis of symmetry. All right, this one. It's a little bit more complicated, but can I factor it? I think I can. So 4 times 9 is 36. So I need the factors of 36 that are going to add to give me negative 12. Now, I don't necessarily know what those are, so sometimes I'll take in my calculator and go like 36 divided by 2. Well, 36 divided by 2 is 18 and 2. Well, that didn't work. 36 divided by 3, 12 and 3. That's not going to give me 12. 36 divided by 4, 9 and 4. Not giving me 12. 36 divided by 6, 6 and 6. That'll give me negative 12. So I have 4x squared minus 6x minus 6x plus 9 equal to 0. So again, I'm going to GCF these two. Then I'm going to GCF these two. So the GCF of these two is 2x. So 2x minus 3 minus 3. If there's a negative here, always take it out, and that's going to give me 2x minus 3. So I'm left with 2x minus 3 times 2x minus 3. Notice that these two, this is just coincidentally the same. These two are the same. That's what it should be. I don't need that one. All right. Now, no matter how many times I solve this equal to 0, x is going to be equal to 3 halves. So 1.5. And also because it's my only point on it, I know that this is also my vertex. That's my axis of symmetry. Okay, and that's my vertex. Which means the vertex is at 3.5, 0. So, or 1.50. So how do I find my other points? So I'm going to go exactly 1.5 out, because adding 1.5 gives me a nice number of 3. And then if I go the other way symmetrically, that's going to be 0. So I'm going to plug 0 into my equation over there. I always like plugging in zeros because it makes it easier, because all of that goes away. And I'm left with 9. So this is going to be 0 and 9. And this is going to be 3 and 9. So 1, 2, 3. And there's that one graphed. And then just to reiterate the question asked, which says what is the solution, or what is the x-intercepts, or what is the roots, again, all of that answers the same question, and that's this here. This is the solution to the graph. 3 halves. X is equal to 3 halves, or x is equal to 1.5. Either of those is correct. All right, next problem. So let's get everything on one side. So I have 1/2 x squared minus 6x plus 20 equal to 0. So this one does not seem as easy to factor. Anytime you have a leading coefficient here of a number, I would not factor it, even when it's a fraction. So I would use negative b over 2a. So the negative times a negative is a positive. 2 times 1/2. That reduces to 1, so that's a 6. Take the 1/2, plug it in. Take the 6 rather and plug it in. This is the axis of symmetry, right? X is equal to 6. Right there. So plugging it in, 36, half of 36 is 18, minus 36 plus 20. So I have 18 minus 36 plus 20, and that gives me 2. I don't know what my graph just did. So this is equal to 2, so I have 6 and 2. So 6, 1, 2. Now, since I know that this graph is somehow going like this, and it does not cross the x-axis at all, it's not going to cross here. It doesn't cross there. So you remember at the beginning when I said if we're looking for the solution and we can tell it's not going to cross here, we're going to have no real solution. There is going to be an imaginary solution, but there is no real solution. And just so that you could finish seeing what that graph looks like, so if I'm at 6 and 2, and I chose numbers that were 2 away so that I could keep whole numbers, this would be 4 and 4 and 8 and 4. So 8 and 4. So this graph somehow looks like this. You can see it does not cross the x-axis. So this has no real solution. It will have an imaginary one. Alright, so solve by graphing is one solution. Another way that you can solve these equations is to use their square roots. So when I just have two terms, that's almost always when I'll use square roots if I can. So I'm just going to solve this equation like I would any other. 4x squared equals, what is that, 7, 8? Divide by 40, divide by 4, divide by 4, x is equal to 20. So now remember when you're solving for the square root, the inverse operation of a square is a square root, so you have to take the plus or minus square root of 20. If you remember from Algebra 1 how we reduce this, you have to go into your perfect squares. So this is 4 and 5. Perfect square root of 4 is 2. So your answer is plus or minus 2 square roots of 5. Now when we go to solve b, b is going to be equal to -9. So I have 3x squared is equal to -9. And if you remember from Algebra 1, so now I have x squared equal to -3, you can't take the square root of a negative number yet. I'm going to stress that word yet. So for the moment, we have no real solution. Very shortly, we will be getting to ones that do have a solution. So this would be x is equal to plus or minus the square root of -3 if I were to finish it. But remember, this is where the negative comes in. So for now, I can't say that enough, for now, this is no real solution. Alright, so for this problem, I'm just going to... Alright, this one's a bit complicated, and I'm going to have to throw some reminders at you from Algebra 1 for it. So in order to get rid of this one first, I am going to multiply by the inverse to get rid of that fraction. Because it's multiplication, I'm allowed to do that. So I have x plus 3 squared equal to 25 over 2. Now I'm going to go ahead and get rid of the square root. Remember when you get rid of the square root though, it's the plus or minus. So I'm taking the plus or minus of 25 over 2. Now I'm going to do some work over here in like the margins of my paper. If you remember from Algebra 2, you cannot leave an irrational number in your denominator, which means this bottom has to go. So I'm going to multiply both in the top and the bottom by the square root of 2. So when I reduce the square root of 50, well, the perfect square root that goes into 50 is 25. The square root of 25 is 5. So I'm left with 5 times this 25 times 2. 5 comes out over 2. Okay, so this is how that got reduced. Now back over here to this problem, I'm going to subtract 3 from both sides, plus or minus, and now I'm going to bring down what I reduced over here. So I have 5 square roots of 2 over 2. This looks ridiculous, but this is actually what I want. That's your answer. This is going to require you guys to remember how to reduce your square roots. Alright, let's see what these do. Alright, solve the equation using the square roots. So again, I'm going to subtract 14 from both sides. 2/3 x squared equals 6. Get rid of that. X squared is equal to 6 times 3 is 18, divided by 2 is 9. X is equal to plus or minus the square root of 9. Took the square root of both sides. X is equal to plus or minus 3. Well, that one worked out nice. We're going to subtract 1. Negative 2x squared is equal to negative 7. X squared is equal to 7 over 2. We're going to take the plus minus the square root of both sides. So again, you can't leave this as an irrational number. That's going to be the square root of 14 over 2. Square root of 4 is 2. So x is equal to plus or minus the square root of 14 over 2. 14 can't be broke down. There's no perfect square root that will go into 14. I had to think about it. Alright, let's see what this one does. Now this one I'm going to start off dividing by dividing by 2. So I have x minus 4 squared equal to negative 5 over 2. Taking the square roots of both sides. Now, I don't have to do anything else with this one. I don't have to rationalize it because of this negative on the inside. For today, for now, this has no real solution. There is an imaginary one where we're going to take it and pull the imaginary number out of it. We'll get there. We're not there yet. Alright, so zero property product. So what does the zero property product? That's just when we've been factoring, and we've been doing that. Okay, so we're going to just solve this by factoring. So I have x squared minus 4x subtract 45. So I need the factors of 45. That's 9 and 5. The 9 is going to be negative because that's negative. So I have 9x squared minus 9x plus 5x minus 45 is equal to 0. Again, grouping. Grouping here. Grouping here. So I'm going to group these two. GCF those two. So this is x minus 9. GCF of that is 5. So I have x plus 5 times x minus 9. So x is equal to negative 5 and x is equal to 9. I solved it. Okay, find the zeros. Again, I don't care if that says find the zeros. I don't care if it says find the solution. I don't care how they ask this question. The 4 different ways to ask the same question, we're going to do the same thing to it. So 2 times x is 24. I need the factors of 24. They're going to add to give me 11. So 12 and 2, 6 and 4, 8 and 3. That's what I want. So I have 2x squared minus 8x minus 3x plus 12. I'm going to group these two. And then I'm going to GCF those two, group them. It's the grouping method for a reason. Okay, and I like the grouping method because it doesn't matter if A is 1, 2, 10, 50, 100, this method works. GCF these two. GCF, now remember if there's a negative here, you're always taking it out. GCF the 3x and the 12 is the 3. These two will always be the same. This one and this one will always be the same. So this is 2x minus 3 times x minus 4. Now all of this is equal to 0. So I have 2x minus 3 is equal to 0, and x minus 4 is equal to 0. So when I solve for x, I get x is equal to 3/2, and x is equal to 4. And this one? Oh, there's a few of them on here. Alright, so this is 7 and 5. So x is equal to negative 7, x is equal to negative 5. This one, you got to get one side equal to 0. So then I have to find the factors of negative 6. 3 times negative 2 is negative 6. So that's going to be negative 6 and 1. So I have 3x squared minus 6 plus 1x minus 2. And that's where I'm going to go GCF that one, GCF that one. So 3 times x minus 2. Oh, I forgot the x. And then if nothing is in common, you can always pull out a 1. And then again, these two are always going to be the same. This one and this one. So I have 3x plus 1 times x minus 2. So x is negative 1/3, and x is 2. Find the zeros, same thing, but these two only have 2 terms that I can start off right away just GCFing this. So x times x minus 8, so x is equal to 0, and x is equal to 8. Whew, 4 and 49. This one's going to take a minute. Let's see, 4 times 49 is going to give me 196. So I have no idea what the factors of 196 are. So 196 divided by 2 is 98. 196 divided by 3, nope. 49 and 4. I'm up to 12. 196 and 13. Aha, found it, 14. So 14 times 14. Okay, so then I have, let's see, 4x squared plus 14x plus 14x plus 49. GCF. So GCF these two. GCF this one. So when I GCF the first one, let's see, 14 and 4, I think is only 2. That gives me 2x plus 7. 14 and 49 is 7. So that gives me 2x plus 7. And I know I did it right. You always know if you do these right because these two terms are always the same. So as long as those are always the same, you've done it right. So I have 2x plus 7 times 2x plus 7. Or written more simplistically as 2x plus 7 squared. Again, equal to 0. This one only has one solution. X is equal to negative 7 over 2. Alright, this is a pretty standard formula for dropping an object on Earth. Now, this is the formula for Earth. If this was for a different planet or other forces, this formula would be slightly different. But this h sub o means the initial height. So what was the initial height that it fell from? So if it fell from a height of 200 feet, it would be negative 16t squared plus 200. Our container happened to drop from a height of 50 feet, so ours is going to be h is equal to negative 16t plus 50, because our height was 50 feet for this problem. All right, so at what point does it land on the ground? So you're going to set it equal to 0, because the ground would be 0, right? That's where it hits it. So we're going to subtract 50 from both sides. Divide both sides by negative 16. And then I'm going to reduce the 50 and the 16. Well, we'll leave it as is for now. So we have 50 over 16. So now I'm going to take the plus minus of both sides. 50 over 16. So this is going to reduce. We already saw the square root of 50 was 5 square roots of 2 and 4. Plus or minus, I guess I'm putting it out in front. Now, we're going to reduce the negative here. Why? We're going to reject the negative solution because time has to be positive, and that's what t stands for. So in our case, while this would go to the other side, we're going to reject it. So in your calculator, you can do 5 times the square root of 2, divide that by 4, and you're going to get approximately 1.8. But again, we're going to reject the negative because I can't have negative amounts of time. So it takes approximately 1.8 seconds for it to hit the ground from a height of 50 feet. Okay, so 1.8 seconds to hit the ground. All right, that solves part A. Now it says find and interpret h1 minus h1 minus h1.5. So what does that mean? So we want to know what it is after 1 second. Like, what's the difference between 1 second and 1.5 seconds? Where is the height of this container to hit the ground? So that's what the h1 is. So let's find the h1 first, which is where is the height after 1 second? So negative 16 times 1 squared plus 50. And I used my calculator and that gave me 34 feet. And then when I wanted to know what it was, where was the container after 1.5 seconds? After 1.5 seconds, the container was at 14 feet. So how far did it fall between 1 second and 1.5 seconds? It fell approximately 20 feet. So the container fell 20 feet from 1 second to 1.5 second, or seconds, I guess. All right. So what if the container dropped from a height of 80 feet? Now this is what I was telling you a second ago. I said we're going to use the standard form, which was, this is the pretty standard form for this, is negative 16 squared plus whatever your original height is. So how would that change? I forgot the t. How would that change my problem? Well, now instead of being 50, it would be 80. So there it is for 80 feet. So how long did it take to hit the ground after 80 feet? Well, solve for 0. So t squared is equal to, dividing both sides by 16, that's going to give me 5. So t is equal to plus or minus the square root of 5. Now, again, we're going to ignore the negative part because you can't have negative amounts of time. And the square root of 5 is approximately 2.23. So it took about 2.2 seconds or 2.23 seconds for it to hit the ground. So how does that change B? So now if I want to find the height, not the height, I'm sorry, the 1 second, where it was after 1 second, so that's going to give me 64 feet. That's where it was after 1 second. Where was the container at 1.5 seconds? So again, in my calculator, I'm doing negative 16 times 1.5 squared. I'm literally doing that as I'm talking to you. Plus 80. Helps if I type it correctly. That gives me 44. That's not going to change, though. I'm still going to have 20 feet between those two. All right, so now what I want you to do, and please follow directions. There is a Google form in Schoology that I want you to answer. Explain what method you would use to solve each of the following quadratic equations. So answer this on the Google form in Schoology. I'm only going to grade this Google form. Do not submit it on a separate document. And tell me which method would you use just looking at these. There isn't really a wrong answer. I just want to know what you're thinking. All right, now you can start homework.